Okay, let's look at 3.1, quadratic functions. And you should have some experience with working with quadratic equations and maybe even quadratic functions. Actually, you do. In the previous section, we graphed some quadratic functions. When we did some shifting and reflecting of that basic shape x squared that was a parabola. So we'll look more in detail at these quadratic functions. First thing is to recognize some of the characteristics of a parabola, do some graphing, determine if the parabola gives us a maximum or a minimum, and then work with some applications that involve minimum or maximum value. So let's take a look at our quadratic functions. They have many, many applications, like the path of a projectile, but we've got to get through the theory of quadratic functions before we can look at the applications. The print didn't come out very well, but one of the basic forms that you'll see a quadratic come in is the ax squared plus bx plus c format. It's just the basic format for a quadratic function, where we have an a, a b, and a c, and we'll get into the quadratic formula later on, but that's just a form that our quadratic function can come in. When we have parabolas, when we have these quadratic equations, quadratic functions, the graph will always be a parabola. We want to get some detail about our graph. When we have our parabola, it'll open either up or down, and the part that determines that is this value of a in front. If a is greater than 0, which basically means a is positive, our graph will always open up. If a is less than 0, that front coefficient is a negative number, then our graph is going to open downward. Now every parabola has a vertex. We'll call it h comma k. Right there would be our vertex. And if our parabola opens upward, we describe that vertex as being a minimum. It's the lowest point on that graph, so it's referred to as a minimum. If our parabola opens down, because a is negative, the vertex here is interpreted as a maximum. And for every parabola, there is an axis of symmetry, which is represented with a dotted line, goes right through the middle of the parabola, and the axis of symmetry always occurs at x equal h, that first coordinate of your vertex. The axis of symmetry is always a vertical line at x equal h. So our parabola can come, or our quadratic can come in two formats. The one we mentioned here, or the one we're more familiar with from the previous sections when we did some translations and transformations of functions, is this x minus h squared plus k. This is the standard form, but all the listings above are still going to apply. If a is less than 0, it opens down. If a is greater than 0, it opens up. So same thing applies. Now this one, we can automatically grab the vertex as h comma k. There is h, there is k, your vertex just drops out as h and k. But we've got to remember to do the opposite sign for h. The reason for that is we're following our rules for shifting and reflecting. And if there is a number inside here, that means it's a left or right shift, and we go in the opposite direction, so we take the opposite sign for h. Same sign for k. We'll have to find some x-intercepts of these parabolas for these quadratics, and for the x-intercepts, we set the function equals 0. For the y-intercept, we find f of 0, or basically we just let x be equal 0. And we'll plot those points and connect the dots and graph our parabola. So let's look at an example. So here's one in our standard form. F of x equal negative 2 times x minus 3 squared plus 8. If we think about that one, that's one from previous section where the basic shape is a square, as a parabola. It gets shifted 3 units to the right and 8 units up. Well, from that we can figure out what our parabola is. So let's first check out how it's going to open. This parabola opens down because the front coefficient is negative. So the parabola opens down. What does that tell me about my vertex? My vertex will be a max. Let's actually find the vertex. We just need the h and the k for our vertex. The h drops down, the k drops down, but we do the opposite sign on h, so it's 3. Same sign on k, so it's 8. Vertex drops out. Let's work on the, what's next? Oh, y-intercept. For the y-intercept, we just basically let the x be 0. Let x equal 0. So let's go to the function. It'll be negative 2 times 0 minus 3 squared plus 8. Let's see, negative 3 squared will be 9 times negative 2 will be a negative 18 plus 8, which is 10. So the y-intercept is at 0, 10. And let's get into the x-intercept. The x-intercept, it says to let f of x equal 0 and solve the quadratic equation. So let's take the function negative 2x minus 3 squared plus 8, set that quadratic equal to 0 and solve it. Well, this is a format that's easy to solve, and we'll start by first taking the 8 over. Negative 2 times x minus 3 squared is equal to negative 8. We take the 8 over. Then we divide by negative 2, which will give me x minus 3 squared equal to 4. Then we square root both sides of this equation to get rid of the square. Don't forget the plus or minus. So we get x minus 3 equal plus or minus the square root of 4, which ends up being 2. So the solutions will look like 3 plus or minus 2, which actually breaks down into 2 distinct answers. 3 plus 2 is 5, 3 minus 2 is 1, and those are our x-intercepts. Obviously, they're not that easy to find. They involve us having to work through solving quadratic equations. And this is one type of technique we can use to solve that quadratic equation. Now let's look at graphing this out. Let's first plot the vertex. So the vertex is 3, 8, so I'll go over 3 and up 8 and plot that vertex. So there is the vertex, which we said is a maximal, or maybe we didn't say it, but since it opens down, the vertex is a max. Let's plot the y-intercept. It is at, I lost a sign somewhere. Yep, that's negative 10. Oops, sorry. That's a negative 10. So when I go to plot it, I realize if it was positive 10, it wasn't going to work. So I made a mistake. Down here at negative 10 is my y-intercept. And let's plot the x-intercepts. 1 at 5 and 1 at 1. Now everything should be lining up with respect to that vertex. Our vertex is here. We have the intercepts that we need to go through, and we can scribe that parabola. So that's all the information we need. Obviously a lot of information to graph our parabola, but you must be able to find all this information. Grab the vertex, find a y-intercept, and find the x-intercepts. Now there are going to be some situations where the x-intercepts won't exist. And since we have to go through a lot of work to find an x-intercept, I suggest we stop and assess the situation before we find the x-intercept. We'll do that in this next problem. Okay, where to go? See if it'll let me scroll down just a little bit. Okay. The next one, f of x equal x plus 3 squared plus 1. I've got this one set up where it's just in a basic translating format where we just need to move it up, down, left, right. But we also want to get more detail on it, like x-intercepts and y-intercepts. So let's first decide, how does this thing open? Well, based on what's in front, it opens up. which means my vertex is going to be, if it opens up, your vertex is a min. Let's actually find the vertex. It's just going to be the h and the k that drop out of the problem, opposite sign on h, same sign on k, and let's work on the y-intercept. And we're just going to let x be equal to 0. So let's go to that function and plug in a 0. 0 plus 3 squared plus 1 will be 9 plus 1, which is 10. So the y-intercept is at 0, 10. Now here's what I was talking about. We're going to stop right here and assess the situation before we go any further, because I don't want to find x-intercepts for a problem if the x-intercepts don't exist. So let's plot our information. Our vertex is negative 3, 1, right there. Our y-intercept is up here at 10. And we know that this parabola is opening upward. Will it cross the x-axis? No, because of where the vertex is and it's opening upward, there will be no x-intercepts for this problem because this graph will never cross the x-axis. So if I assess the situation first, then I'm going to realize that there are no x-intercepts. So I'm done with the problem. I've gotten all the information I needed. I've gotten my y-intercept and my vertex, and that's all I can get for this problem because there are no x-intercepts. Well, that's when our quadratic is in this standard form. When our quadratic is in this other form, the ax squared plus bx plus c format, we want to find all this information that we found above, but the vertex is not as easy. It doesn't drop out as h and k. I don't have it in that format, so I have to have an alternate way to find my vertex. And this is just a quick little formula to find the vertex for a quadratic that happens to be in this format. And remember, a vertex has is an ordered pair, x comma y. So we have to find both values. The way the x value is found is we use this little formula, negative b over 2a, where the b comes from the middle coefficient, so we take the opposite of b and divide it by twice the first coefficient. So negative b over 2a will calculate the x-coordinates. So I would need to go through and do that arithmetic. But I have to calculate his partner. I have to calculate his partner. And his partner is going to be the value I get when I plug this in. So I need to plug in my answer. To find y.